Hello everyone, welcome to Techno Herald online. Today we are going to start our lesson 1. In lesson 1 we will study about the basics of vector calculus. In basics of vector calculus we will study about scalar and the vector quantities. Then we will study about addition and subtraction of the vectors. Then we will move to the product of the vectors, where we will study about the cross product of the vectors, scalar product of the vectors, and then we will study about the triple product of the vectors. And then we will study about position vector and displacement vector. Now we are going to start a new subjects, that is electromagnetic field theory. So you can see here electromagnetic field theory. So electromagnetic is made up of the two terms, that is electro and the magnetic. It means that in this subject we are dealing with the concepts of electricity and the magnetism. Okay, actually this subject forms the basis of the whole electrical engineering. In electrical engineering we study the different subjects like the power system, network theory, electrical machines, and various other subjects. But this subject, that is electromagnetic field theory, forms the basis of all those. In this subjects we study about the charges, we study about the currents, we study about the magnetic fields, and lot of things we study related to the electricity and the magnetism. Okay, so let's take an example. Suppose that this is a block. Okay, when we provide, or you can say let us consider this is a point charge. So it is a point charge. Let the value of this point charge be plus q magnitude, which is given by the coulombs. So it is a point charge, so it will emanate an electric field around it. Okay, this point charge will emanate the electric field around it. Since it is emanating an electric field around it, so any other charge, let's suppose this is a charge q1 and this is charge q2, then any other charge q2 coming close to this charge q1 will experience a force, so it will have to do some work in order to come towards this charge q1. So whatever the work this charge q2 is doing is stored as an energy in this charge q2. So from there we generate the concepts of the potential. Okay, so first we have the charge, then it creates an electric field around it, then there is a concepts of the potential. Okay, now when this charge will be in motion, then the current will get produced. The charge at rest, we study the charge at rest, the concepts of charge at rest in electrostatics, and when this charge comes into the motion, we get the current. We already know that the charge in motion nothing but the current. We know that I is equal to, that is current is equal to Q upon T, where Q is the charge and T is the time. That is, charge flowing per unit time is nothing but the current. That is, when the same charge is present at rest, we study these concepts in the electrostats, and when the same charge comes into the motion, then it becomes the current. And after the current, what comes? When this current I flows through any conductor, we know that the current carrying conductor produces the magnetic field around it. Okay, then we get a magnetic field around it, and the direction of this magnetic field is given by the right hand thumb rule. Okay, where the thumb represents the direction of the current flowing through the conductor and our curling fingers denote the direction of the magnetic field around it. So we have started with the charge in motion becomes current. Okay, then if a current is flowing through any conductor, then a magnetic field is produced. Okay, and this magnetic field when becomes a relative motion, we got the magnetic field here, and we already know that when there is a relative motion between the magnetic field produced by the current carrying conductor and any other conductor, then voltage get produced, which is given by the Faraday law. What does the Faraday has explained us? The Faraday has told us that whenever there will be the relative motion between the magnetic field and any conductor, then the potential will get produced around the conductor. Then how does it possible? How it is possible? Suppose that there is a magnetic field, okay, then a potential. After we have the magnetic field here, then by the Faraday's law, what the Faraday's had told us, Faraday's laws, that whenever there is a relative motion between the magnetic field and the current, what we will get? We will get a potential V. Okay. Now, we have started from the charge. Charge in motion was the current. Current flowing through conductor produces magnetic field. Okay. And by the Faraday laws, we know that whenever there is a relative motion, we get the voltage or the potential. When this voltage is provided, suppose that let us take an block consisting of many number of the charges. This is a plus charge, this is negative charge, plus negative, consists of many number of charges. So initially all the charges are in random motion, that is there is no any alignment of the charge. When we provide this voltage V to this block, suppose that I have connected this voltage V that is being generated by using the Faraday law to this